In this video, we will be talking about distance and displacement, two quantities in physics that help us track the motion of a moving object. The first is distance, and this is the one that you're going to be more familiar with. It just simply tells you how far an object has traveled. So, for example, from my classroom to the local Chick-fil-A, it's only about half a mile. So if I leave my school and travel to Chick-fil-A, it's only going to be 0.5 miles. Well, that's how far I'd have to travel in order to get from one place to Chick-fil-A. Now notice I didn't say which direction I had to go in order to get to this Chick-fil-A. That tells us something very, very important. That tells us that distance is one of those scalar quantities. So remember, a scalar quantity tells us a magnitude. So in this case, our magnitude would be 0.5 miles. Okay? However, it does not include a direction. So from here to Chick-fil-A, it is 0.5 miles. Now notice I included the unit miles. Distance can be measured in miles. In our physics course, you'll see things more like millimeters, centimeters, maybe even kilometers. But our ultimate goal is to get everything into meters. That is going to be our standard unit of measurement for distance. Okay, relatively simple. Displacement is also relatively simple, except we're going to add on one more component. Displacement is the shortest distance between the starting point and the end point of any motion. Okay. So what I like to describe it as, it's the distance between where you start and where you end. So for example, if I leave school now and head to the airport, I have to take a kind of funky path to get there. I have to go down the highway and then back up to get to that airport. And Google Maps says it's going to take me about 11.5 miles. Okay. Well, what if I had the ability to fly to the airport? I know it's kind of silly to think about flying to the airport, but if I could essentially drive my car straight there without having to take the curves and turns of the road, how could I get there? Well, I would take the shortest distance between my school and the airport. The shortest distance is always going to be a straight line between two objects. In this case, if I look at the scale of Google Maps, it says that it's only going to take me 6 miles to get there. Okay. But notice, this is in a very different direction. This one takes me around some curves and around exits and on-ramps of the highway. This is a straight shot. Okay, it's definitely another direction. So we would say this is 6 miles northeast. Okay. So notice I used direction. Well, direction and a magnitude, 6 miles northeast, tells me that this is a vector quantity. Remember, vector quantity is a quantity that has both magnitude and direction. Okay. Just like distance, displacement can be measured in miles. You'll also see millimeters, centimeters, kilometers. Once again, our aim is meters. We want meters. And a direction. Our direction for displacement, we can use one of two things. We can use north, south, east, west, and any combination of those, northeast, southwest, etc. Or I can use an angle. And that's going to be our more precise direction measurement. So let's look at an example to see how these two can play out. So I'm going to tell you about the adventures of Billy Bob. So as you can see, this is Billy Bob. He's a great stick figure, I know. So Billy Bob is going to travel from point A to point B. So we could say school to, let's do Chick-fil-A. It's going to travel from school to Chick-fil-A. Now, I know we just said that Chick-fil-A was half a mile from school, so this is kind of silly. We're going 8 meters. That is not a good measurement, but we'll just go with it. So Billy Bob is hungry. He leaves school. He goes to Chick-fil-A. How far did he travel from A to B? So we need our distance and our displacement. Well, this is going to be really easy. Our distance is just 8 meters. That's how far he traveled. Our displacement from A to B is still 8 meters. But remember, what's the other thing displacement has to have? A direction. Well, then how do we determine direction from this? Okay. Well, typically, if we're looking at a flat sheet of paper, we're going to say that the top of the page is north, and then south would be opposite, and we have west and east. Okay, well, that's not too bad. So if Billy Bob went from school to Chick-fil-A, this would be in the eastward direction. So he went 8 meters east, and you can abbreviate that as an E if you'd like. Okay. Well, let's say that after Billy Bob finished up at Chick-fil-A, he decided he wanted to go to Ben & Jerry's for some ice cream. So that would take us from A to B all the way to C. Well, now this path is going to look slightly different. So let me use a different color here. So we're going to go from A to B and then to C. How far has he traveled now? Well, his distance, that would be 8 meters plus 4 meters. So 8 plus 4 would be 12 meters. Now, what about his displacement? His displacement is the shortest distance from start to stop. So if we're looking at the shortest distance from start to stop, we're going to go directly from A to C. Notice how that makes a triangle with these two legs, and this is the hypotenuse. And you might have guessed it. We're going to use our Pythagorean theorem here. If you don't quite remember the Pythagorean theorem, that's okay. We're going to get lots of practice with this over the course of this class. So essentially I'm going to take the square root of each of my legs squared, and that's going to give me a number of, I'm going to round up, 8.9 meters. So my displacement is going to be 8.9 meters. Okay. Well, I also need a direction. And while in this case it can be very tempting to say, oh, this is just in the northeast direction, the reality is northeast is an exact 45-degree angle. And we can't do that in this diagram, because this is not a 45-degree angle. Okay. I'm going to use inverse tangent. Inverse tangent of 4 over 8. And that's going to give me an angle of about 26.6 degrees. Once again, if you're not quite up to speed on trig, no worries. We're going to build that into the course and get some practice in class. Plus, there's some links on my website that can help walk you through those. So the most precise answer for our displacement would be 8.9 meters at 26.6 degrees. Okay. Well, let's continue Billy Bob's story. So Billy Bob has gone to Chick-fil-A, he's been to Ben & Jerry's, and he says the only thing that can make this day any better would be grabbing a friend at home. So let's see that Billy Bob meets up with Bobby Joe. So that means we're going to go from A to B to C all the way back down to D. So if we go A, B, C, D. What is our total distance now? Our total distance now would be, let's see, we do the original 8 plus 4 plus an additional 8 here at the top. And that would give me a grand total of 20 meters. Okay. Well, what about my displacement now? My displacement is the distance between my start point and my stop point. So what is the distance between A and D? Well, that's just 4 meters. Notice how my displacement has gone down. Okay, so my displacement has gone down. I'm going from D to A. And then what direction am I? I'm only 4 meters away from my starting point, and I'm north of my starting point. Okay. And then the last case we want to look at is after Billy Bob has hung out with Bobby Joe, he decides he needs to go back to school. Maybe lunch has ended, and he has to return. So we go from A to B to C to D, back down to A. We've made one complete square. How far have we traveled? So we've got 8 plus 4 plus 8 plus 4, all four sides of our rectangle here, the perimeter, is going to be 24 meters. What about our displacement? Well, we started at A, and now we're back at A. So what's the distance? Displacement. Our displacement would be 0. If we start and stop in the same place, have we really gone anywhere? No, we haven't. Our displacement would be 0. Now notice I'm not going to include a direction here. If you start and stop in the same place, there's no need to say I went north or south or east or west. It doesn't matter. You've ended up in that same exact place. I want you to look at these two columns. I want you to make an observation here. Notice our distance. As Billy Bob continues his travels and adds on more and more stops, our distance increases. Our displacement, on the other hand, it increases as we get further away from our starting point. But then as soon as we turn around and start heading back, it decreases. So displacement can go either up or down, while distance can only go up. And I want to leave you with this thought. There's a device in your car called an odometer. Your odometer measures one of these two quantities. So think about, does your odometer measure distance or displacement, and why? Be sure to tell me the answer in class.